All right, so we're going to cover graphing and more. There's many different ways of solving systems of equations. A system is just two or more equations working together. You're trying to find that one common answer that works for both equations. And in the future, we're going to be finding that one common answer that works for all three equations. It'll be entertaining at least. So number one, we want to graph both of those. So let's all follow along here. If you have different colored pens, right now is a great time to use them. Let's use the top one in red. It crosses at 3. And from this point, I'm going to go down 2, down because it's negative, down 2 and always run to the right 3. So down 2 over 1, 2, 3, put a dot right there. Ladies and gentlemen, this is my line. Whoops, kind of crooked. Anyway, let's do the bottom one in blue. This one crosses at negative 2. And from that point, I'm going to go up 1 over 1 because my slope is 1. So up 1 over 1, up 1 over 1. And you will clearly see where these two lines cross. They cross right here at the location 1, 2, 3, 1. Okay, so 3, 1 is the solution to this first system. So this beats the heck out of thinking, well, what number could I plug in here and here I could plug in here and here and it'll work on both. So let's not use mental math. Let's actually graph, since we know that this red line represents all the answers to that red equation. This blue line represents all the answers to that blue equation. And we want that one single answer that works for both. That would be the point of intersection, which is the location 3, 1. If you wanted to double check your answer, all you have to do is plug in the 3 for x right here and the 1 for y right here. So if you did plug in the 3 right here, it would cancel out, and the 1 over here, you'd end up with something true. 1 equals negative 2 plus 3. That's also 1. 1 equals 1. True statement, right? So you double checked it on the top one. If you do the bottom one, it'll work as well. 3 right there. 3 take away 2 is 1. And if you plug the 1 in for y, it'll say 1 equals 1, which is also a true statement. So whenever you get an answer, you could plug it back into your system and make sure that it works for both equations, and you'll be absolutely positive that that's a correct answer. Number 2, the problem with number 2 is that it's not in y equals mx plus b form, so we have to do a little bit of work here. Subtract x. Our new equation is going to be y equals mx plus b, which is negative x plus 3. That'll cross the y-axis at 3. Put a dot there, and from that point, what's my rise and my run? Down 1 over 1. Down 1 over 1. So I draw my line. Let's move on to the bottom equation. I'm going to do this one in blue. Divide by 2, divide by 2, divide by 2. Now I have it in y equals mx plus b form. Y equals negative 2 divided by 2 is negative 1 with an x minus 3. This one crosses at negative 3. And it does go down 1 over 1. Let me use that pattern backwards to make my line longer in the opposite direction. So what do I notice about these two lines? They're parallel. So what am I going to write for this solution? Okay, so and that's good that you guys brought that up. What we classify this would definitely be an inconsistent system. But when I'm asking for the answers, if I tell you to solve it, you're going to say no solution. No solution. By the way, the instructions do say to solve the following systems, double check your answers, and then classify. So yeah, we are going to classify them as well. I've only been solving. I apologize. So the first one, the answer was 3, 1. And let's classify it now. What do we classify number 1 as? Consistent, independent. Perfect. Consistent, independent. I don't have space, but you guys know what I'm talking about. Number 2, they did not cross. There is no solution. So if I say solve it, you're going to say no solution, right? There is no answer. Now, if I ask you to classify it, what are we going to classify it as? Inconsistent. Okay, but again, I want you to know the difference. When I tell you to solve, you're going to say no solution. That's the actual answer. But if I say give it a name, if I say classify it, that's when you say inconsistent. How about, I think you guys could handle number 3. Let's jump to number 4 here. I need to get both of these ready to graph before graphing. So let me get the top one and get y by itself by adding 3x. Adding 3x, I'll have negative 2y equals 3x minus 8. I'm going to divide by negative 2, divide by negative 2, divide by negative 2. My equation in red will be y equals negative 3 over 2x plus 4. So I am going to graph this one in red. It crosses at 4. 1, 2, 3, 4. Crosses way up here at the edge. I go down 1, 2, 3 over 2. Down 1, 2, 3 over 2. So here's my red line. Now I want to do the same for this other one, but in blue. I need to get y by itself. So the easiest way on this bottom equation to get y by itself is to divide everything by 4. Divide by 4, divide by 4, divide by 4. We will get y. Let me write it this way. Y equals, and if I look at this, negative 6 over 4, I could at least reduce that by 2. 6 over 4 reduces down to what? 3 over 2, and that is a negative 3 over 2. And then this final one over here, 16 divided by 4, that's positive 4. So I put a plus 4 after the 3/2 x. And what was that? It's the same line, ladies and gentlemen. So if I did graph it, it would also cross here, and it would also go down 3 over 2, down 3 over 2, and it ends up being the same exact line. So if I asked you to solve it, which I do ask you to solve it, what would you say? Not classify. Right? If I say solve it, infinitely many solutions. Now, I heard you say all real numbers. That's a good guess, but it's not technically all real numbers because you're not talking about every single number there is out there, right? You're talking about an infinite amount of x and y values. So that's what we need to write down for the answer. The answer is infinitely many solutions. I guess we could abbreviate IMS, infinitely many solutions. But just understand that there's an infinite amount of answers. Okay, now the classification, classify, what do we classify that as? Consistent, dependent. I'm running out of space here. Consistent, dependent. Okay? So there's a big difference between solving and telling me the answer and classifying it, giving it a name. Okay, the word wall up there is for giving it a name, for classifying. So, is graphing a great method to solve systems? Yeah, it's great. If when you graph them, you could find that point of intersection, right? But like, what if you graphed one line and graphed another line, and let's say they don't cross in this little tiny graph that you have. Maybe they'll cross like at positive 15 and negative 35. Maybe they cross way down here off the graph. Does that make sense? So then graphing is not fun, unless you have a graphing calculator, all right? So we need to learn other methods besides graphing because the point of intersection might be way off of the little tiny graph that we have. So there's substitution method. I rarely use this one unless it's already ready to go, but let me walk you through it anyway. The steps are right here. Step 1, pick an equation and solve for a variable. So there's many roads in math, right? You could pick the top one and you could pick to solve for x, but there's always shortcuts or the quickest path possible. So which equation do you think is easier to work with, the top one or the bottom one? Bottom one. So I'm going to pick the bottom equation and I'm going to solve for a variable. Do you think it's easier to get x by itself or to get y by itself? X in this case. Now check this out. If I said I want to get y by itself, I'd have to subtract x, rewrite the whole thing, and then divide by 3 and divide everything over here by 3. Does that make sense? But the quicker option is to just get x by itself, because all you have to do is one step. What's that one step? Minus 3y. Minus 3y. So there it is. We have x equaling negative 3y plus 3. Okay? So again, step 1 is to pick an equation. You could have picked the top one and solved for x or y. You could have picked the bottom one. You could have solved for y, but then again, there's more work. So always think about what's the quickest, easiest way to do it. So that was step 1. Step 2, substitute that variable expression into the equation you have not used. So we pick the bottom one, we have not used the top one. We solve for x. So this is saying that x equals this stuff, right? So I'm going to take that stuff, that variable expression, and I'm going to plug it into the x value of the other equation we have not used right in there. So everybody circle it and draw those arrows. And then let's draw an arrow coming this way, showing our new equation. So that top equation, instead of saying 2x, I'm going to put 2 parentheses. And then I'm going to put the plus 5y, and then the minus equals negative 5. Now inside those parentheses, I'm going to put the negative 3y plus 3. So what did I just do here? With substitution, I plugged it in, and I no longer have x's and y's. Now I just have y's. And when I just have y's, when I have a single variable, I could do the math and solve for that variable y. So let's solve this complicated looking equation. Let's distribute. And by the way, this is a step 3. Step 3 is solve that equation. Get an actual answer. So we're going to get an actual answer, and then after that, we're going to substitute it back into any original equation and solve for the other variable. So let's solve this equation first. 2 times negative 3y is negative 6y. 2 times 3 is 6. No more parentheses, but you still have this plus 5y. You still have the equal sign and the minus 5. Out of those 3 terms, you could combine the like terms. The negative 6y with the positive 5y. What do we get? Negative 1y. Bring down the plus 6, bring down the equals, bring down the minus 5. I'm almost done. What do I do next to solve for y? Subtract 6. What you do to one side, do to the other. We will end up with negative 1y equaling negative 11. Final step will be to do what? Divided by negative 1, divided by negative 1. So y equals 11. And we're still not done. Yeah, okay, so remember, on a system, you have x's and y's, or maybe a's and b's, or c's and d's, I don't know, but you have 2 letters. We have found one of them. We still need the other. So when you have one answer and you need the other, what do? Plug it in into any one you want from the original. So I'm going to go with the bottom one. It looks a little bit easier. We already used both. So instead of x plus 3y, I want to put x plus 3 times 11. So let's all write that out. X plus 3 times 11 equals 3. So we are plugging in an 11 right there. So we really have x plus 33 equals 3. And when we subtract 33, we'll get x equals negative 30. So ladies and gentlemen, the solution to this system right here is negative 30, comma 11. So imagine if I would have decided to get y by itself, get them both in y equals mx plus b, and then graph them. They would cross at negative 30, way to the left, way off the graph, and positive 11. So graphing is not always the best method. As a matter of fact, the only time I would go for graphing is if they're already set up in y equals mx plus b. If they're set up in y equals mx plus b, yeah, go for it, right? And hopefully they intersect where you could see it. So substitution, do we understand that? Yes. Yes. Is it the best method? No. Sorry, it's not the best method. What's the best method? This one right here. It's called linear combinations, aka also known as elimination method. Okay, so the goal here is to combine the lines and to get a variable to cancel to create a new equation that only has one variable, which you could solve. Okay, so what we want to do is take a look at this top equation, take a look at the bottom equation, and we want to combine the lines. I want to combine these x's, combine these y's, but my goal is to get either x's or y's to cancel. So ladies and gentlemen, if I combine 4x plus 1x, will it cancel out? No. If I combine 3y plus 5y, will it cancel out? No. So I need to modify. See, the goal is to get something to cancel. So what do you guys want? Do you guys want to cancel out x's, or do you want to cancel out y's? X's. All right, so if we want to cancel out x's, I need this bottom coefficient value to be what? A negative 4, right? This is a positive 4. I need it to be a negative 4. By the way, we should have learned this already in Algebra 1. So I want this bottom one to be a -4. So I'm going to put parentheses around the whole thing, and I'm going to modify the whole equation by multiplying it by -4. I want to distribute to each and every term. Okay? Now, why would I do that? Because then I will get a -4x right here. -4x instead of x. I'm going to get a -20y. And I'm also going to get -4 times -9. That's a +36. So here's my new bottom modified equation. The top one I did not modify. So I'm going to leave it exactly the way it is. 4x plus 3y equals -2. And now we are ready to combine the lines and cancel out those x's. So if I combine the lines, again, combine the x's, 4x, take away 4x, that cancels out. Positive 3y, take away 20y, that's -17y. -2 and +36, that's going to be a +34. And we end up with a simple one-step equation. So again, you want to modify one equation, or maybe both equations, to get a variable to cancel. And then you could solve for that simple one-step equation. If I divide both of these by -17, I'll get my answer, y equals what? -2. There's one answer. I still need the other. What do I do to find the other? Plug it in. Right? So let's plug it into any one. Which one do you guys want? The top one or the bottom one? Bottom again? Okay, no problem. So we're going to have x plus 5y, but instead of y, I'm putting the -2 right in there, equals -9. So when I do this math, I'll have x minus 10 equals -9. Add 10, add 10. You'll have your final answer, x equals 1. So your answer to this entire system is 1, -2. So if I were to have graphed these, they would cross pretty close to the origin. It wouldn't have been bad to graph these. But linear combinations is the preferred method of of solving. Now let's go back to the original. We decided to cancel out x's by multiplying the whole thing by -4. If you wanted to, you could cancel out y's, but that would have been a little bit more challenging because you'd have to change this top one to a +15 by multiplying everything by 5, and you have to change this bottom one to a -15 by multiplying everything by -3. So like I said, in math, there's many roads to the same place. You just want to pick your roads to be the most effective, the quickest route. Now let's say you weren't too sure about these answers, 1 and -2. What could you do? You could plug them in. You could plug in a 1 up here and a -2 right there. Do the math. It will give you -2. Plug in a 1 right here for x, a -2 for y. Do the math. It will give you -9. That way you're double checking your answers and you'll be absolutely positive that you're right. Now, there are special cases. So if you're working on a system using the elimination method and everything eliminates and you get 0 equals 0, is 0 equals 0 true? Yes, it's always true, right? So what do you think that's going to be if it's always true? Infinitely many solutions. That's what it says right here. If it's always true, 0 equals 0, then you say infinitely many solutions. Visually, that would mean that the line lands right on top of the other line. Vocabulary-wise, you would call that a consistent dependent system. Okay? Now let's read this next sentence. If you're working on a system and both of your terms eliminate, both of your x and your y eliminate, and you end up with something impossible, like 5 equals 3 or 0 equals 4, right? Then you say, no, that can't happen. You say no solution. Visually, that means that your lines are parallel. They do not cross. That means no solution. So we have practice right here. I would like you guys to do these right now. I want to pause it. Go for it. So let's get rid of the y's. That's your best option, getting rid of y's. So if you multiply, and when you do this work, please use parentheses to show that you're multiplying the entire top equation by 3. So we're going to distribute that 3 to each and every one of those terms. And then let's rewrite our top equation right next to it. It's going to be 9x plus 9y equals negative 45. The bottom equation is going to stay exactly the same. 5x minus 9y equals 3. Again, you could have modified the equations to cancel out x's. It's just a little more work because you'd have to modify both equations instead of one. When you combine 9 and 5, you get 14x. When you combine positive 9 and negative 9, that cancels out. We end up with a negative 42 right here. And luckily, when we divide by 14, luckily we end up with x equaling negative 3. And that is one answer. If you need the other answer, all you have to do is plug it in. So when we plug in negative 3 back into which one, top or bottom? Top. Okay, so on the top, it's going to read 3x plus 3y equals negative 15. Plug in that negative 3 right there. You're going to have negative 9 plus 3y equals negative 15. Get rid of the minus 9 by adding 9. Adding 9, you end up with 3y equaling negative 6. Final step would be to divide by 3. Divide by 3, giving you a final answer, y equals negative 2. So your entire answer to this first system is negative 3, negative 2. If you wanted to double check it, all you have to do is plug in both numbers into x and y on both equations and make sure that it gives you a true statement on both. So I would like you guys to do the rest of these for homework, yeah?